2 more examples to look at for homework. We did already one last sketch all together of a sinusoid going through our clues. Then we did one homework example of going backwards. Little tricky, but we got it. What would you do with this one? They still want an equation, but they don't give us a graph. They give us all sorts of, maybe it'll be easier. They give us words. Clues.
Yeah, words are actually really nice to sleep.
Right? Because it tells you clearly. Yeah. Who is this? Sine or cosine? They say a sine curve, right? Cool.
Should we like click all of that?
It's up to you. We're just doing an example, so. If you're one that would never go online to actually see what we were really doing, it might be a good idea. But if you're one like, oh, I'm not afraid of going online and checking it out real fast if I just want to double check and use it. It's up to you. Period of pi, amplitude of 2, right? Phase shift of pi over 2, and a vertical translation up 1. The question is, which one do we care about first? I mean, the period does come first, but if I was thinking about my graph, y equals, who's the sinusoidal axis? They don't say that.
Translation. Amplitude of 2, then it says 0.
No.
Translation.
This is A, right?
Because
We have to ask ourselves, has it been shifted up or down at all, right? Because that would shift the middle. Well, it has been. So therefore, who's my D? 1. Got it. So the middle got shifted up 1. From that, amplitude means go 2 from 1, which would be a 3. Or go 2.
But amplitude was like.
They aren't giving you the
up, and then you can go 2 down.
from the middle, but it doesn't mean at 2 and at negative 2. If the middle's somewhere else, 2 up, 2 down would be somewhere else.
so it would be 3, right?
Yeah, it'll be at 3 on the ground.
So if it doesn't give you E, you gotta do the half of the amplitude.
You're thinking about if you have a graph and you're looking at it, the high, the low cut in half. But this one, they just tell me how much. They don't tell me where it is at all. Amplitude just tells me how stretched it is. But it could be all over the place. So y equals vertical translation up 1. Amplitude, oh, that's easy, right? 2. Sine of, all right, anything else we can easily plug in, like straight away.
The period.
Can't plug him straight in, though. I'll use him. I can plug the pi over 2 straight in. And it's a right phase shift, which means I need to keep the minus, right?
What?
But I need periods formula to find b. Who is the period? Pi. I need to get b from the pi, but pi is not the number that plugs in. Remember, I have a formula for period, 1 over b times 2 pi. Now we have options. If you guys don't like the 1 over b, couldn't, would most of you think of doing that? Well, can I move the b to the other side to get them all nice and up where I want them to be? Yeah. Let's multiply b to the other side. Now I want to get b alone, so I just divide both sides by pi. Who's b? If you think about it, horizontal dilation, if there's a 2, that means cut the period in half. Is this one variation of the answer? Yeah. Could we write it one other way?
Yeah.
Remember how they kind of like have everything multiplied in? So we could also have it 1 plus 2 sine of, multiply the 2 in.
2x minus 5.
Do they both mean the exact same thing? Yeah. Either one is right. I'm fine with either, but maybe the back of the book would have like this pretty form instead of the fractioning form. With words, how do we do? Okay. Graphs are a little tricky. Got to pull stuff out of them. It's a little hard sometimes to see where everything is. Words, they have to be precise, so they give us actual nice numbers. Be careful though. Period is not B. I use the period to solve for B. One more. Come on, you got this. Give whole group high fives, high tens. They need it. There are words. High five if someone is injured. There you go. Don't forget people in the back or people in front of you. And here we go. Here we go. Real quick, before you even think about this application problem, I want you to write down one quick clue that we have not written down anywhere in our notes. Frequency. We wrote down period, wrote down amplitude, wrote down sinusoidal axis, phase shift, but we did not write down frequency. Frequency is something that comes up in application problems. And it comes up when? And it comes up when we're talking about how often something occurs. Well, hold on. Period is how often something occurs or how quickly a whole cycle occurs. What's frequency then? Okay. Yeah.
It should be 2 periods because it goes, then gets back.
But remember, going and getting back is still one cycle. Kind of how often? That's actually kind of still period though. Period says how long. Frequency says how much. How much of the cycle is. Now, let me give an example. If we were talking, what were we talking yesterday? We were talking about paid periods, right? We were talking about every 2 weeks, most jobs, like bi-weekly pay periods, every 2 weeks you get paid, okay? So 2 weeks, that's the amount of time it takes you to get paid. But then I could say something like, okay, well, how much of that period, or what percentage, what ratio, would 1 day be? So you have to take the 2 weeks and you have to say, okay, hold on, if I'm getting paid for 2 weeks, how much would 1 day's pay be? Wouldn't you have to kind of divide that up? That's kind of what's going on. Instead of talking about the full 2 weeks it takes to get paid, thinking about the 1 day's pay. So it's just a little different way of thinking about it. The 1 day's pay is going to be 1 over the 2 weeks. That's what ratio or what proportion you would have if you're just getting paid on like a day-to-day basis and not with commission and crazy stuff like that. And if you're working the same amount of time every day instead of like hourly, where sometimes you work a few hours and then a few more hours or a few less. Okay. So, application. After exercising for a few minutes, a person has a respiratory cycle for which the velocity of airflow is approximated by, boom, equation. It's a sinusoid. We could rewrite it. How would you guys rewrite it? Is there much to rewrite? Yeah. You could pull out that constant, remember, away from the t. Now, they're not making us graph it, I don't think. Maybe they will. But we wrote it in the nice form we're used to. Where t is time in seconds, inhalation occurs when v is greater than 0. And exhalation occurs when v is less than 0. Okay. Find the time for 1 full cycle. Oh, wait, hold on. 1 full cycle. What's that another word for? How much time for 1 full cycle? Period. Oh, well, hold on. We have a formula for that. What's the period? 1 over b times 2 pi. Now, who is b, though? Yeah, how do we do 1 over pi over 2? Flip it. So we can say 2 over pi is the reciprocal times 2 pi. Pi's cancel, and we end up with 4. So, for letter A, let's just answer it nicely down here.
Wait, what was B?
It's pi over 2. What's time measured in? Seconds. If it was minutes, we might have some issues breathing. Okay. So 4 seconds. It takes 4 seconds to inhale and exhale. Huh. All right. For this specific person, not for every person, because as you guys know, our airflow is probably different. It's definitely different from person to person. But letter B says find the number of cycles per minute. How do you do that though?
Build the bridge. You get minutes per second, like seconds are there in a minute, and then like use this 4 seconds, 2 minutes.
How do we get, wait a
Should be
minute,
like-
Build the bridge.
but don't we need cycles per second first?
No, 1 cycle is in 4 seconds. So
So instead of building the bridge, we're just gonna do like division. We can do that. So we can say how many 4 seconds are in 1 minute. You wanna do that? Now that's not exactly building a bridge. I'll show you building a bridge in just a second. But you could say, okay, well I know 1 minute has 60 seconds. So take those 60 seconds, see how many sets of 4 there are, and you guys know there's gonna be
15.
okay, 15 cycles. But if we were to try to do it in the sense of building a bridge, we would actually start with 1 cycle per 4 seconds and multiply by 60 seconds per 1 minute. Does that make sense?
Yeah.
That's how we would actually build a bridge. Then we'd have 60 over 4 once again. We'd have 15 with our units, cycles per minute. Just a quick reminder that we would have had to actually make the first part before we did the bridge. A's done, B's done, C?
We got this.
Are you sure? Oh, come on, we totally have this because we have our nice equation. Who's our sinusoidal axis? Oh, 0. That's easy, right? How high are we going to go and how low are we going to go? What's our amplitude? 1 point. Let's just mark that. Does that sound good? We'll just make the units 1.75. All right. Now, if you guys were thinking like Zoom standard, wouldn't this be really small? Be like, right? But we're zooming in to make it easy to graph. So we have 1.75 up, negative 1.75 down. Where's our, oh wait, it's sine. What's he look like?
It's gonna be
Center.
center. Side center.
Good, sine center, start in the center. And he starts at
0.
0. Yay.
Wow.
There he is. As we're graphing, my question to you is, does this scenario start with someone inhaling or exhaling? Good question. How do we graph? Hold on, we need the period, right? We already figured it out.
Hey.
Every 4. And what's 4? Okay, quarter cycles. What's 4 cut in 4? 1, 2. It's just every 1, right?
Oh yeah, because it's by 1.
Because it's just by 1s, yeah?
Wow.
So then, top, middle, bottom, middle. Dun, 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 dun. Question. Are they inhaling or exhaling first?
They are.
Is it starting with an inhalation or an exhalation?
Wait, no.
Exhale first.
Would you like?
You know what? Exhale first.
Oh wait, no, yeah.
This just doesn't work.
I feel you, Sean.
Just be,
I feel you.
You're
inhaling.
Does it go positive or negative first?
Positive.
So you inhale and exhale like you would probably guess, but a few of you were still trying to do the exhale thing. Alright, so.
You exhale.
You guys are goofs. Ready? Done.
Whoa.
What's that?
Oh.
We're gonna make sure you still know how to do it tomorrow. We're gonna make sure you still know how to do it tomorrow. Alright, turn. Use that chicken side. Not gonna get very far, but we need to get into it a little bit. Let me go get our calendar real quick and make sure we're doing alright.
I need a nap.
Same.
It's okay, you have nutrition. You can kind of recharge, right? No?
No.
What do you guys do during nutrition? You take a nap
Gotta
or
work
lunch?
with the answers to college.
It takes me like
Oh yes.
It's not a
so
recharge.
much.
Okay, I don't mean sleep. I meant like food, caffeine.
I eat during second period.
Oh.
I can't wait for periods anymore. I literally every day there's a baby. Ask Mr. Strike.
Okay, good. We're supposed to be starting section 4.6 today, so we're doing it. Good job, guys. We finished 4.5 first. We were a little behind on him, but that's okay. We're starting 4.6. Remember this Friday, corrections are due for chapter 3, yeah? Now, remember you still have tutoring hours to do? Wait. Regular pre-cal just got back their tests that are similar, not exactly, but similar to yours. If you're working through your corrections, couldn't you pull them alongside and be like, hey, let's do homework together and I'll help you with
When
yours?
you think this is over,
Right? During lunch, I'm so dumb.
if we're looking at it at the same time.
It's so hard.
You could be busting stuff out. Math or chemistry
Because Laura
or
was
physics. Anything mathematics.
doing
Personal
me and
finance.
Brandon were
Wait, I have a question. So I guess once I were to know Lonnie, would that count as
Like, Brandon is always.
Yes.
too?
Because she can get up to 2 hours, like any of you, if there's something you're struggling with, or like it could just be even corrections, like I don't know how to correct this, but I think you do, can you help? You can get up to half of your hours by being tutored to or explained to. Does that make sense? So 2 of you could bust out hours by, or even 3 of you, 2 of you are getting helped, 1 of you is helping, and all of you are getting hours. Huh? If it's like an extended on a certain topic, yeah. All right. What's the title of 4.6?
Graphs of other trig functions.
Oh, who are the 2 trig functions that we've been working on and you're going to finish up in homework tonight? How many more are there? Woo! But, question. Doesn't tangent and cotangent and secant and cosecant come from sine and cosine?
That's you.
Okay. Now, specifically, sine and cosine have reciprocals of cosecant. Sine and cosine have reciprocals of cosecant and secant. So those are directly tied. Tangent kind of is a little deal, even though we can kind of use what we know. So, ready? Lucas' table. Oh, yeah. Doesn't
My
Lucas'
table
table?
does not have zeros in it.
But doesn't it talk about tangent? Okay, so hold on. Let's start with, I'm just going to do first quadrant. I'm not going to go super crazy. Let's start with first quadrant. And then we're going to do our pi over 6, pi over 4, pi over 3, pi over 2. All right. What is, now hold on, we have to work on this one together because it's not in the table. What is, oh no, yeah it is. What's tangent of 0?
Oh,
One. No, zero. Zero.
Right? It's 0. Square root of 3 over 3, 1 square root of 3. Undefined, right? If we were to add
Yep.
to the sum. So, starting at 0. So tangent of 0 is 0. Oh, well, I guess we can do radians, huh? Okay. Tangent of 0 is 0. Question, what's tangent of pi over 6? Good. Square root of 3 over 3, which is approximately 0.5-ish, maybe a little bit less. What's tangent of pi over 4? What's tangent of pi over 3? And what's tangent of,
Undefined.
wait, what's undefined mean?
1 over 0.
Ready? Tangent of, focus, tangent of 0 is 0. Because now, remember, our angles are on the x-axis. So we have 0. Here's our pi over 2. There's our pi over 4, our pi over 6, and our pi over 3. Roughly. Okay. So we have square root of 3 over 3, which is approximately 1/2-ish. Then we have 1. Actually be a little bit less than 1/2. Sorry, I said that. A little bit less than 1/2. Then 1. Square root of 3. What's square root of 3?
1.73.
Yeah, it's in between square root of 1 and square root of 4, so it's in between 1 and 2, closer to 2 sides. So 1.7-ish. Oh, that's going to actually keep going up, right? So 1.7-ish. Guess why tangent of pi over 2 is undefined? Because it's just going to keep on going up and up and up and up and up and up and up. And it's never going to actually hit infinity. An infinite answer is actually called undefined. because we don't have an actual point on a vertical asymptote. So an infinite answer is called undefined. And guess what happens if we go this way? Tangent is 0. If we were to go down to negative pi over 6, guess what? Tangent is negative 1/2, and then it's negative 1, and then it's negative 1.7-ish, and then it's negative infinity. So tangent actually has like a concave down part and then a concave up part. And at negative pi over 2, it's going to be undefined as well. Now that was me going through and walking through each of these different values and why tangent is what it is. But let's go ahead and write it a little bit nicer and prettier, okay? So we don't actually need all those points. So we could make pi over 2 right here. We could make negative pi over 2 over here. Tangent is going to have a point of inflection in the center. It's going to roughly be that shape. But the crazy thing is, just like sine and cosine, tangent repeats over and over and over again too. And so tangent could keep going past this, but it's going to have the exact same cycle, meaning it's going to have another vertical asymptote. But can you guys figure out where this vertical asymptote is? Not pi. This is 1 pi over 2. This is 1 pi. This would be
3 pi over 2.
because we have 1 pi over 2. Think tick marks. 1 pi over 2, 2 pi over 2, 3 pi over 2, right? And if I was to keep going this direction, I could actually keep drawing tangents. It's going to keep on cycling, etc., etc. But let's talk about a few important characteristics, like vertical asymptotes. Where do they occur? X equals, now, here's a struggle. I can't just say every pi over 2, because that would include the pi's and 2 pi's that don't actually work. But I can start by saying x equals pi over 2, start there, and then go pi away. I had to skip 2 tick marks to get to the next vertical asymptote. So start at pi over 2, and then go pi, meaning pi over 2, go 2 tick marks, pi over 2, go back 2 tick marks. I either add pi or I subtract pi. That end looks funny. Period. Well, if it takes tangent 2 tick marks to complete, look, pi over 2 this way, pi over 2 that way. How long is one cycle? 1 pi plus 1 pi. Sorry, 1 pi
It's
over 2
never
plus
going
1
to
pi.
reach pi. It's going to be.
Yeah, but we still say it's confined within that pi
Oh, but pi
distance.
is not a defined number either. It goes like it's closer.
That's true too. Yeah, that's true too. Domain and range. I don't know why they're so close to each other. That's funny. Domain. Well, did we already say that vertical asymptotes tangent can never actually hit? Range, how high, how low, all real numbers. It's going to go forever high, forever low. That's different than sine and cosine. Sine and cosine were bouncing, right? They were stuck within. But domain for tangent, x cannot equal any of its little vertical asymptotes. And symmetry, what symmetry do you guys see? Even? No. Remember that one? Origin symmetry, yeah. Another word for origin symmetry, do you remember what that was called? To be odd. To be odd. No. Here's a question. Because it's being flipped over and down, right? Over and down. Do you think tangent can be shifted, stretched, compressed too? Yeah. So we need to work really hard tonight on getting really good at sines and cosines because they're the beginning. And then we're going to come back tomorrow and talk about tangent and then talk about cotangent and figure out, okay, are there tricks for that one too? And you guys know me, are there tricks?
Yeah.
Yeah. So we need to get good at them. So practice on sine and cosine tricks tonight. Come with any homework questions tomorrow. Bye guys.
Bye.
Later, Gators.